Fantastic. So this is where we are. Now what we can do is we could say, well, this was our first element that we've assembled in there, and we're happy with that. Now I'm going to delete this and say, now let's look at our second element. Okay, so let's look at the second element. And we're going to go through the same logical process. And then we're going to step by step assemble that as well. Okay, so let's see what we get out. So our first element is down in there. Okay, so let's look at the second element. The second element, make sure it's dark enough. Yo, it's not great. Okay, hope it's clear. Really hope it's clear enough. Let me see if I can get another cookie roller. Okay, let's see how this goes. Okay, so the second element is now again in this local world of tie -1, 1, and 0. No local numbering, so the local. This is node number 1, 2, 3. That's the convention that we have. And then it's associated here for the second element. We've got this is x3, this is x4, and this is x5 for our isoparametric formulation. So we can use that to get those mappings out. So this is what we have. Okay. And now what we know is also that in the global system, let's call it the global here at the bottom. Global. Okay, in this global world, I know that this is associated with node number 3. This is associated with node number 4. This is associated with node number 5. Okay, this is just the global node numbering. And so this is associated with unknown Q3, Q4, Q5, where in the local we'll have it associated with Q1 bar, Q2 bar, and Q3 bar. Okay, so when I write down my little stiffness matrix, essentially what I have is, I hope it's, let's just write it a little bit closer. I have the local Q1 bar, Q2 bar, Q3 bar, and the local force balance at node 1, force balance at node 2, force balance at node 3. Okay, so let's just make sure put our nodes properly in. Okay, that's that. In the global scale, we essentially have, okay, in the global scale, I know Q1 is associated with Q3. I know that Q3 locally is associated with Q4. And I know that Q2 locally is associated with Q5. Okay, and the same goes for node number 1 is associated with node number 3 of the force balance. Force balance at node 3 is associated with force balance at node 4 in the global, and force balance at node 2 locally is associated with force balance at node 5 in the global. That's it. And now let's say we've got our entries into this matrix. So we stopped last time at F, so there's the entries, again the symmetry of the stiffness matrix, and now we can just go and say let's add it into this stiffness matrix in our big global stiffness matrix. So locally, in this local first row of the stiffness matrix and node 1 of the stiffness matrix, so what we see here is that everything in row 1 in terms of the force balance of this local stiffness matrix is associated with row 4 in the global stiffness matrix. So that's the first thing we see there. Okay. The next thing we see is that local node, this column 1, is associated with Q3. So G will go into Q3 position. Okay. So that's where the G must go in. And I don't override what's here. I add to what is here. Oh. Now it's I add to what is here. Oh, this is terrible. B plus G. I add. Okay, so this is, and this process of adding it in is called assembly. Simple as that. Okay, so this is important to understand. When there was something there, I'm adding to the same node, because essentially what we see here is that this third row and this third column is shared between the elements. And the reason for that is these elements share this node Q3. Okay, so you can see that there's a contribution of stiffness in this global stiffness matrix coming from element 1, and there's a contribution to the stiffness of the element 2 towards the stiffness matrix globally towards that Q3 node. So that's why we see that. Okay, so that's that. And then we can say a third row associated with the second column, this J must go into the Q5 position, so third row must be J in there, and then I can say this must go into the fourth position, okay, must go to Q4. Okay, that's that. Then we could say this second row of this stiffness matrix must go into the fifth row in terms of the global force equation, so this will go into J. H will go into the fifth position, L will go into the fourth position. Okay, and then this is, oh, what did I write here? Sorry. Fifth, J must go into the third position. Ooh, J must go into the third position, not in the first position, what is that? Then this third row will go into the fourth row in this global stiffness matrix, so this will go into the third position. Okay. This will go into Q5, and this will go into with the association of Q4, and that's what we have. Okay, there is the assembled system. All of these other things here are zeros. There are zeros, and so typically nothing will get added in there. So this is how that stiffness matrix look, and we can see, as a sanity check always, is nodes that are shared will get stiffness contributions from more than one element. So it's nodes that are shared between elements will get the stiffness matrix contributions from multiple elements, and that process is called assembly. Now we have the global stiffness matrix, and this global stiffness matrix, is essentially a composition of 1, of 2, 3, 4, 5. It can be an infinite of 100 or 1,000,000 finite elements that contribute towards this building up this stiffness matrix. And the process that we take is just taking structure, breaking it into multiple elements. Each element we can go and compute with our local system of the local numbering of 1, 2, 3, and the local nodes Q1, Q2, Q3. And all that we have to do is to say, oh, we just have to map what does the force balance of this local numbers map to in terms of the global numbers. And that's just by looking at saying this node is here in this element 1, this node is here for element 2, this node is here for element 3, or for element 2 to say this node here is there, this node is there, and this node maps to that. And that's essentially what we have. And once we've got this global numbering associated with the local numbering, which is important, we can now assemble this local stiffness matrix in the appropriate places in the global stiffness matrix. Okay, next what we can look at is how do we now go about solving this? Okay.